Hello friends, in this video we will talk about smart environment. The environment challenge of modern cities is that of conserving resources, and these resources are in short supply such as water and many similar type of resources. Also, protecting some resources from pollution is also a matter of concern such as water, air and land, and also protecting the audible environment from sound pollution. The environment challenges also draw on sustainable practice to limit greenhouse gases emission, control global warming and protect biodiversity of the earth. First we talk about water conservation. Many urban regions have a need to sense and monitor water resources as the population of these cities is creating shortages of this commodity. Varying rainfall patterns that replace water bodies, draining out water from upstream dams to canals, and poor use of available water have forced many cities to manage water through smart methods. Water bodies such as lakes and reservoirs are monitored by sensors for their levels, the amount of inflows they have from streams and rainfall, and also the amount that is consumed by urban water needs. These levels are sensed by water meters and the data is provided on continual basis to central system that computes the water level. Water related measurements also include those of rainfall, humidity, soil composition, sunlight and temperature. In rural areas, such data is provided to farmers to make decisions about cropping times, cropping patterns, and irrigation. Monitoring is also done with satellite image. Satellite image creates data that gives an indication of the spread of lakes and streams, flows in rivers and canals, and the depth of water bodies also. When wastewater is released from urban areas in the local lakes or local reservoirs, this too is measured and accounted for by using technology. Researchers have developed many complex mathematical models that are used to predict availability of water from these water sources at different times of the year. In many cities, one of the main challenges of water conservation is that of preventing leakages. Most older cities have water pipes that are many decades old and also they are underground, thus making them difficult to access and check. To address this problem, some cities are installing pressure gauge in the pipes. This pressure gauge indicates the level and pressure of the flowing water. A lower pressure is usually desired as that leads to lesser leakage where leaks are present. The system of sensors provides an accurate estimate of the extent or stock and flows of water in the network of pipes. When more water is demanded in some regions, the flow are increased by automated pump controllers that allow more water to be pumped into systems. When water is in less demand, the flows are reduced and with that water pressure is also reduced. This has the twin advantage of reducing leakage and also of reducing the energy required to pump water. This is because as the water is pumped only when needed. Cities are also encouraging water conservation at housing complexes, and in Bangalore, for instance, housing complexes and gated communities have to implement rainwater harvesting as part of their compliance with municipal laws. IT is being used by these communities to monitor water levels in tanks and sumps. This information is used to control pumps to fill water and also to drain water when needed. Also, pollution control is a big matter of concern nowadays. Pollution control is enabled by monitoring air quality at different points in the city and aggregating this data to arrive a comprehensive picture. Typical measurement sensors record data pertaining to levels of carbon dioxide, carbon monoxide, nitrogen dioxide, humidity, temperature, and pressures. Some sensors will also monitor light quality and vibration levels, whereas others may particulate matter and ozone. Such sensors are typically mounted on kiosks at points on city street, on top of traffic signals, or on top of building. The data from sensors is aggregated and overlaid on a map of a city to obtain a visual image of different components of air quality and also their presence in the city. Hotspots of pollution are thus identified where air quality is particularly poor, and this is used to direct executive action. As example, cities may divert traffic away from hotspots of pollution to control the air quality of the city, especially the air quality of that particular hotspot. Sensors are also used to visually observe sensitive areas in the city, such as factories or warehouses, where there is a possibility of increase in polluting activity. These are surveillance cameras and that may be observed by citizens on a volunteer basis and help to identify potential problem areas. The city of Pittsburgh in USA has experimented with such an approach. Another approach for measuring air quality is to provide citizens with sensors that are connected to GPS-enabled smartphones that feed data from different points in the city to a central server. The advantage of this approach is that the sensors are mobile and check the air quality. Water pollution is also a matter of concern for urban areas. Some cities have implemented sensors to monitor the extent of sewage flowing through the underground sewage system. The purpose is to treat the sewage before it is permitted to mix with the other water bodies and also to control the extent of sewage that is produced and unleashed into rivers and oceans. Weather and rainfall measurement sensors are also used to predict if excessive rainfall is likely, which often lead to overfilling stormwater drains that leads untreated sewage into water bodies. With these measurements, infrastructure managers in cities can divert excessive water to alternate drains without letting them enter into the sewage system. Friends, so in this video, we have talked about smart environment and how we can care our environment with the use of information technology. For next video, we will talk about a different case study, a different concept for this video. Thank you.